Alright, in this short video, I'm going to show you how to rationalize the denominator. Now, the first thing I wanted to show you was something that I mentioned in a previous video. And that is when I covered H. And H here, notice that you have the same exact terms, but there is a plus and a minus sign here. And when that happens, when you FOIL this binomial times binomial, the middle terms cancel. So let me show you that one more time before we get it. So in H, we have the square root of 6 plus 4 times the square root of 6 minus 4. Now, if you notice this, you'll see that the middles will cancel out, but I'm going to FOIL all of this. The square root of 6 times the square root of 6 is the square root of 36. Square root of 6 times negative 4 is negative 4 radical 6 again. And yes, I did do this in a previous video, but I'm going back over it. 4 times radical 6 is 4 radical 6, and 4 times negative 4 is negative 16, because I really wanted to show you that whenever you have a situation like this, these are called conjugates of each other. So this word here, conjugates. And whenever you have this type of situation, the middles will always cancel out, which is pretty nice. So we started with radicals, but I'm going to show you that we don't end with radicals. So the square root of 36 is just 6, and then I'm just going to bring down this minus 16, which equals negative 10. So even though we began with radicals, we ended with just a regular number, negative 10. So that's going to be helpful for our next concept, which is rationalizing the denominator. So the factors a plus b and a minus b are called conjugates, and basically you have the same a and b, obviously, but we just have a different sign in the middle. They are called conjugates. Conjugates are useful when rationalizing the denominator, since the special product pattern a plus b times a minus b equals a squared minus b squared. What that is really saying is that a long time ago mathematicians decided that you can't keep radicals in the denominator for your final answer. So you need to get the radicals out of the denominator, or sometimes I've even seen problems that say rationalize the numerator, but most of the time it's rationalize the denominator, which basically means get rid of the radicals from the denominator. And the way that you can rid of these radicals is by using the conjugate of, for example, radical 5 plus radical 2. What is the conjugate of radical 5 plus radical 2? It is just radical 5 minus radical 5 minus radical 2. And of course, I can't just do that. I have to do the same thing in the numerator, because that's equivalent to 1. And that's how we're going to manipulate this in order for the radicals to go away. Again, if I multiply conjugates together, advantage of that is getting rid of the radicals. So let me show you how the radicals go away. So let's multiply all of this. Now in the numerator, I just want you to write down the 4, and I want you to put their parentheses and put radical 5 minus radical 2. We're not as much as concerned about the numerator as we are the denominator. And we're going to FOIL this out. Now, if you already know the middles will cancel out, that's an advantage, because you really don't have to multiply everything. But because this is your first time seeing this problem, I'm going to FOIL this out. That's radical 5 times radical 5, which is radical 25. Then radical 5 times a negative radical 2 is negative radical 10. Radical 2 times a radical 5, positive radical 10. And radical 2 times a negative radical 2 is negative radical 4. Alright, as you can see, the middles cancel, which is nice. So already we got rid of a couple of those radicals. Alright, continue to keep your numerator the same. No need to multiply that out. Square root of 25 is 5, and the square root of 4 is 2. So your final answer is 4 times radical 5 minus radical 2 over 3. Alright, next we have 2 over radical 7 minus 1. And we need to make the point about a. Notice no radicals are in the denominator anymore, and that was the entire point of what they call rationalizing the denominator. Alright, next we have 2 over radical 7 minus 1. So again, we have a radical in the denominator. We need to get rid of it. So we're going to multiply numerator and denominator by the conjugate. So the conjugate of radical 7 minus 1 is just radical 7 plus 1. Radical 7 plus 1. Again, write 2 times radical 7 plus 1. We need to keep it like that. And then in the denominator, we're going to FOIL that out. So radical 7 times radical 7 is radical 49. Radical 7 times 1, radical 7 minus a radical 7 minus 1, since negative 1 times positive 1 is negative 1. Notice again, without fail, the middle terms cancel, and you have 2 times radical 7 plus 1 over square root of 49 is 7, and you have a minus 1 here. So that's 2 radical 7 plus 1 over 6. And this is one of the reasons why I asked you not to multiply the numerators out, because you probably would not have noticed that this could be simplified if you had distributed the 2. Now, since we kept it out, we could easily go back and simplify. 2 goes into 6 3 times, into itself 1. So the final answer is square root of 7 plus 1 over 3.